Now that we have seen the drawbacks of adopting conventional philosophies in work culture, in this lecture we will see how by adopting CI/CD practice into any software development culture help you eradicate those drawbacks and can help you achieve faster deliveries with highest software quality possible. And trust me, the deliveries would be so fast that on every single commit you would be able to send a new software release into production. Having said that, let's start integrating CI/CD practice into our old model. Guys, since CI/CD is not a tool, technology or a coding language, it's mere a work culture. So to evolve CI/CD culture into a company, your developers do not need to learn any new skill. Rather, from now on, they just have to change and improvise the way they were working till now. They only have to adapt certain set of operating principles that will help them to deliver code changes more frequently and reliably. I'll try to add those principles in our previous mobile app example and will help its team to adopt CI/CD work culture. The first change achieving CI/CD is to use a shared common repository where all the codes of any team or team members is present. See, as of now, developers in conventional work culture were using task-specific branches in which the final code integration was done occasionally after weeks or months. And by task-specific branch I mean like front-end team has their own branch to work on and back-end database team created their own branch and they would merge their branches at last. But now, there would be a one code repository in which all the codes are present and all the edits or additions to the code should be committed back to this repository. In our example, you can say that there would be no longer front-end team branch or back-end team branch containing exclusive codes of their own area. Rather, you would have one code repository where all the front-end, back-end or whatever is needed for a full-fledged application to run are present and developers will work on that shared code. Developers can still have their own individual branches for their development, but all of their final code should be then committed back to the shared code repository so that it always remains updated with the latest code changes. Also, this commit should happen frequently. It can be multiple times a day or at the very least at the end of day. Whatever changes the developers are making into their own branches, they should make a habit to commit them in the master repository at least once a day. Now by doing this, we are very much tackling the problem of integrating those gigantic codes at the very end of development. If the developers are committing their codes daily, then you see the integration of the whole code is automatically getting happen. At any point of time, you get the holistic view of all the codes getting prepared across various teams of the project, right? Now once this integration starts happening, you will start thinking of to remove this build and integration team. But wait, build and integration team also does the task of compiling the code and building the software package. So before we can roll them off, first we need to assign those jobs to someone who could perform them. This is where build server come into picture. Here, we deploy a dedicated build server which itself can automatically compile the code, build the packages out of them, and if specified, would perform the unit and UI testing for the software. So with build server being deployed, there will be no need of human to compile or build. Everything will be handled automatically. So the next continuous integration principle coming out of this is that whenever a developer commits the code, that commit will automatically trigger the build server to run various test cases, compile the code and build the package out of it. And in case if there is any compilation error and the build fails, that error is immediately sent out to the developer who has just triggered that build. Upon getting the error notification, he will be resolving that issue after minutes of its creation. And if you go back, this was a big drawback in the traditional work culture. Earlier the code defects which were taking days to surface are now coming up in few minutes after the code commit. From now on, no matter how many commits are being done by developers within a day, build server will automatically build them, test them within few minutes or so. Now moving next, to make deployment ready software quickly available, one thing that can be changed is this operational process. As of now, the operations team is manually reading the instructions and then create environments accordingly. But if you have ever seen that instructions file, you will notice that those are basic instructions only and can be carried out by executable scripts like Unix scripts. Steps like command to download any requisite libraries, set environment variables, paths, and other things can be easily done via Unix scripts or new advanced techniques. and these scripts developers themselves can build. So the next principle is to automate the operations part by some scripting language. Now guys, you don't really assume that a person who is creating the mobile application code can also write these scripts. No, it is not expected. The development team here in DevOps, as the name suggests, is an intermix of both developers and operations team with the roles clearly defined to them. Where app developers will create the application code, the operations people, now being included in the development team only, would be parallelly writing those Unix scripts. It's just their manual efforts are eliminated, not the operations team itself. But yeah, they have to now upgrade themselves and learn a bit of more coding than before. Now as far as the third drawback is concerned, while writing the unit cases for the application, you can also write some functional test cases and automated quality assurance test scripts to shorten these feedback cycles. Now guys, I'm very easily saying this to write some automated quality assurance test scripts to remove any other human effort from this complete life cycle. But this requires a high level of experience and confidence in what you are doing, as automating the quality assurance test will make the developers to release the new build into live market with just a single click on commit, which definitely has huge risk involved in it. So that is why this automated acceptance testing, I would say, is subjective to adopt or not. Anyways, the last drawback was non-streamlined and unautomated process. Undoubtedly, in CI/CD culture, you induce a lot of automation in the whole process. We have already seen the manual efforts of build and integration team are now replaced by an automated build server. Operations team's manual efforts can be replaced by some scripts. And believe me, this is just the trailer of automation. At the highest level of automation, as I'm saying all along in this course, you will just make a single code commit in the repository and your change will be live in production after going through the automated tasks of compile, build, test, and then deploy. Now guys, recalling all that we have learned so far and clubbing them together, we can deduce that in CI/CD, we tend to create a pipeline of test, build, deliver, and release. And all these steps work in a seamless manner for faster and error-free software deliveries. And how and where to write these individual steps is further there in the course with full details. Excellent. So this is how, if your developers are adopting this working culture, then you can say that you are implementing CI/CD into your project, and undoubtedly adapting CI/CD culture can help an organization to deliver changes and new releases more frequently and reliably. And with this comes the end of this section here. Starting from the next section, you will be introduced to GitLab, and progressively you will learn how to smoothly transit any development cycle to GitLab CI/CD. Thank you.